My name is Harsh and today we are going to discuss the seventh problem from CP-31 sheet by TLE Eliminators under the 1100 rating range. So let's move on to the TLE Eliminators website, and we have clicked this CP-31 sheet. We have the 1100 rating parameter clicked, and here is the clickable link to our seventh problem. So let's move on to the problem. So the name of the problem is building an aquarium. So the problem says that you love fish and that's why you have to decide to build an aquarium. You have a piece of coral made of n columns, the ith of which is AI units tall. Afterwards, you will build a tank around the coral as follows. You will pick an integer h greater than equals to 1, the height of the, which is basically the height of the tank. Build walls of height h on either side of the tank, then fill up the tank with water so that the height of each column is h unless the coral is taller than h. Then no water should be added to this column. For example, you have this array, you have this I, and you will be end up total using 8 units of water. So as you look, you have corals of height 3, 1, 2, 4, 6, 2, 5. 3, 1, 2, 4, 6, 2, 5. Now if you decided to build a tank of height 4, so how much water, how many units of water you will require? So the corals that have the height lesser than 4, they will have water on their top. Do you all agree? You have this coral that is having height 3 and you decided to build a tank of height 4 and you are pouring water in it. So the corals that have height lesser than the height of the tank, they will have water on their top. Now if you look, how much water do you have above the coral 1 that is having height of 3? You have 1 unit of water, right? Because the height of the tank is 4. Similarly, above 1 you have 3 units of water, above 2 you have 2 units of water, above 4 you will not have any water because the height of the tank is 4, so you will not have any water over here. Similarly, for height 6 you have no water, for height 2 you have water of 2 units of water, and above height 5 you don't have any water. So the total units of water that required when you decided that the height of the tank you are going to keep is 4 is 8. If you simply sum up these values, 1 plus 3 plus 2 plus 2, it will come out to be 8. Now what is the question? In the question they have told you that what you want that the height of the tank should be as long as possible. But you have a restriction. The restriction is that you can use at most x units of water to fill up the tank. But you want to build the biggest tank possible. So the question is that what is the largest value of which you can select. So I hope the question is clear. We will understand it, how we can do it by the help of this particular example as well. So first of all, let's understand the constraints. So the constraint is you are given the size of the array as n, which is of the order of 2 into 10 power 5, and the maximum units of water that you can fill is of the order of 10 power 9. And then you contain n space separated integers of the array, that basically AI represents the height of the ith coral, and it is of range 10 power 9. And they have also mentioned that sum of n over all the test cases does not exceed 2 into 10 power 5. So what you need to output? You need to output a single integer h, that is the maximum height the tank can have. So you need at most x units of water to fill up the tank. And you have approved that under these constraints such a else always exists. Okay. Now let's understand first of all what the question is, and then we can proceed further. So let's take this particular example only and understand our question with that. So you have 3, 1, 2, 4, 6, 2, 5. Just a minute. Yeah. 3, 1, 2, 4, 6, 2, 5. These are nothing but the heights of the coral. Okay. So if I would like to draw the figure, do that. So this is my 3. This is my first coral that is having height of 3. Then my second coral having height of 1. Then my third coral having height of 2. Okay. Then my fourth coral has height of 4, fifth coral has height of 6, sixth coral has height of 2, and seventh coral has height of 5. Okay, so if I just simply draw this, this is nothing but 3, this is nothing but 1, this is nothing but 4, and this is nothing but 6, and this is nothing but 5. Okay, now tell me, if I tell you that I want to fill and the value of x is also given to you, so the value of x is, let's suppose, 9. Okay, this is also something that is given to you. Now if I, let's suppose, tell you that I want to build a tank of height 4, so I am building a tank of height 4. Okay, so this is the tank I built and it is of height 4, so this value is 4. Now tell me the amount of water that you will require. This is the amount of water that the entire tank will be filled with. Do you all agree with me? Excuse me. So this is the amount of water that you require. Can you tell me what is the total units of water you require? So if you just simply see, this was of height 3 and the height of tank is 4. So over here you have 1 unit of water. Above this particular coral you have 3 units of water because this is of height 1 and the height of the tank is 4. Above this you have 2 units of water. Above this you have 0. Above this you have 0 again. This is basically 2. This is basically 2. Let me not write it over here. Okay. So, and this unit of water is again 2. So if you sum up total units of water, it is nothing but 1 plus 3 plus 2 plus 2, which is nothing but 8. So when you decided that, okay, you are going to keep a tank of height 4, you would require 8 units of water. Now, this 8 is well within the range of x. The question says that you can maximum use x units of water. Do you want to increase the height of the tank as much as possible? The question says that you can maximum use x units of water. And you can see that this x is well within the range, that is 8 is lesser than equals to 9. So you can always say that, okay, you can always build a tank of height 4. Now let's suppose instead of deciding that, okay, you are going to fill the tank with you are build a tank of height 4, you decided that you are going to build a tank of height 5. Okay, so you are going to build a tank of height 5. Once you decide something like this, tell me the units of water that you require. So above this particular coral, which is of height 3, you will require 5 minus 3 amount of water, that is equal to 2, right? So this is the entire tank. This is the amount of water that you are going to require. Okay, so if I simply write up these values, this is nothing but 2, this is nothing but 4. Basically the height of tank minus height of the coral. Okay, this is nothing but 5 minus 2, that is 3. This is nothing but 5 minus 4, which is 1. This is nothing but 5 minus 2, which is 3. So when you decided that you are going to keep the height of the tank as 5, this was when the height was 4. And when you decided that you are going to keep the height of the tank as 5, tell me the units of water you require. You will require 2 plus 4 plus 3 plus 1 plus 3, which is equal to 4 plus 3, 7 plus 4, 11 plus 2, 13. Do you all agree? Do you all agree? So can you do this? Can you keep the height of the, can you use the 13 units of water? The answer is no. So you can't build a tank of height 5. Okay. So I hope the question is clear, like what actually question wants to say. Question wants to say that you are building a tank of some height. So once you are doing that, you will require some units of water because you are pouring water inside the tank. So if the units of water is lesser than equal to what the given amount is, you can build an aquarium of that height. The question says that tell me what is the maximum height of the tank that you can keep. So this is actually what the question is. I hope all of you understood the question. Now before going to solve this, before just starting the intuition and understanding how we can actually solve this question, let's look up to actually the expected time complexity of this problem. Expected time complexity. So if you look, the heights the height of the number of elements in this array A, that is basically the heights array, is of the order of 10 power 5, isn't it? So anything that works, any complexity that works in square root of n or log n or n omega of n, omega of n log n, something like this will always work. N square root n will also work. But if you are having complexity of that is something order of n square, square root n, n square log n, something that is greater than n square or n square, it will never work, right? So you have to think of some time complexity that will work within this range. So I hope you all understand that looking up the constraints, what's the expected time complexity is. So let's proceed with the solution then, how actually we can solve this question and what's the basic idea. If in this question, when we were building a tank of height 4, we required 8 units of water. When we were building tank of height 5, we required 13 units of water. Let me make a slight change and tell you that I am building a tank of height 3. So let's suppose I am building a tank of height 3. So now this is my height. My height is 3 and I am building a tank of height 3. Okay. I am building a tank of height 3. Yeah. Just a minute. Yes. Okay. So we are building a tank of height 3. So tell me the units of water that you will require. So this is height 3. So you are going to fill your tank till this particular point. So this is the units of water which you are filling, and if I simply sum up these values, this is 2, this is 1 and this is 1. So when the height of the tank is 3, you require 2 plus 1 plus 1, which is equals to 4 units of water. Similarly, when the height of tank was 4, how much units of water you required? 8. If I am not wrong, you can check. We required 8 units of water. Similarly, when the height of tank is 5, you require 13 units of water. Do you all agree? Are you all able to see something? That as you are increasing the height of the tank, the units of water that you require is also simultaneously increasing. And why is this happening? It's like quite logical, right? Because if you are increasing the height of the tank, so you will require more and more water to pour, isn't it? Like when the height of the tank was 4, you did not require any water above this coral. But once the height of the tank increases to 5, you will require amount of water above this coral as well. And correspondingly, for every coral, the amount of water that you require will increase by 1 unit once you increase your height of tank from 4 to 5. So as you are increasing the height of the tank, the amount of water that you need to pour is also increasing. Now, there are two things that are working against each other. What are those two things? You want the height to be as large as possible. But there is a constraint. That the maximum units of water that you can fill is given to you. So just imagine, you are increasing your height from 1 to 2, then to 3, then to 4, then to 5, then to 6, then to 7. Okay? And the value of units of water is also increasing. Let's suppose I tell you that you can't fill water above this the height of the tank is 6. When the height of the tank is 6, the amount of unit of water that is required, that is, let's suppose x1, is greater than x, that is the maximum allowed capacity. If this is the case, can you say me that I can't build a tank of height 6? Now tell me, if I can't build a tank of height 6, will I be able to build a tank of height 7? Because we know that as we increase our height, units of water is only going to increase. So let's suppose the value of the maximum capacity was 20, and for height equals to 6 you require 22 units of water, and you told that okay, for height 6 I can't build a tank. But again, for height 7 the units of water that you will require will definitely be greater than or equal to 22, right? And since 22 is greater than 20, so this amount will also be greater than 20. So I can say that if I can't build an aquarium of height 6, I can't build an aquarium of height 7 as well. I can't build an aquarium of height 8, 9, 10, something like this. I can't build them. So in this case, the maximum height of the aquarium that I can keep is nothing but 5. Do you all agree? Do you all agree? So how we can approach this question? One thing is that we can just iterate our height array from 1 till some maximum level point, and once we reach to some height for which the capacity exceeds the maximum allowed capacity, in that case let's suppose that height is 6, so we can return 6 minus 1, that is 5, which is the maximum allowed height of the tank. But just keep one thing in mind, the height of the coral is of the order of 1/9 and x is also too large. In that case, if you just iterate over all the heights, if you are iterating over all the heights, and for every height tell me the amount of time that you require to check the units of water. If I give you, let's suppose height equals to 4, tell me the amount of time that you will require to check the amount of units of water you require. What you will do? You will go to each and every coral and see the amount of water required for that particular coral's height, isn't it? So that would require, you are basically traversing over the entire array for every height. So that would require a time complexity of big O of n. And if you do this for every height, so wouldn't you feel that the time complexity will be n multiplied by h, where h can go up till like can be greater than 1e5 or 1e6 or 1e7? Do you all agree? So this is something that we can't do. This will definitely produce TLE because this is something a solution of big O of n square type, isn't it? And this will never work. So you have to think of something that works in lesser than this. So how we can then solve this? See, there is a method called as binary search on answer. And how we can apply this over here, let me tell you. Let's suppose the height of the tanks is 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, and so on. If I tell you that you can't build an aquarium of height 6, so you know that if you can't build an aquarium of height 6, you can't build an aquarium of height 7 as well, 8 as well, 9 as well. And if I tell you that you can build an aquarium of height 5, so do you all agree that I can build aquarium of height 4 as well, 3 as well, 2 as well, and 1 as well? Isn't it? So if I just construct a function, that returns me true for a particular height, so what is this function? This function takes the height of the tank as input and it returns either true or false. So it is basically a Boolean function. It is returning me true if I can build an aquarium of height h, and it is returning me false if I can't build an aquarium of height h. So do you all agree that if these are my heights, so the result of this function for this particular heights will be something like this: true, 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 false, 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 and all the remaining values will also be false. So if I apply binary search over this heights, now see what I want the height value for which I got the last true. Do you all agree? I want the height value for which I got the last true. So if I simply apply binary search on heights, and if I say you that okay, I am having height h, and there are two possible results, that either I can get result as false or result as true for this height of the aquarium, isn't it? If I get result as false, do you all agree that I am standing at some of the heights that is over here? Do you all agree? In that case, can I say that if currently I am looking for answer in the range starting index to ending index, that is basically how we initialize our indexes of the array. So if I am looking my answer within this range, and let's suppose my height that I chose was mid, which we generally just divide, take the middle part of this starting index plus ending index. So if our height is just mid, and for that particular mid height we got result as false. So do you all agree that from this mid till ending index I will not get my height, because if we have a false result for this height, we will have false result for all other heights as well. So do you all agree that I should reduce my search space and I should shift my ending index to mid minus 1? Because I know that from mid till ending index I can't have my result. So in that case I can shift like this. But if I get my result as true, do you all agree that I may be standing somewhere over here? In that case, what you can do is you can modify your answer with the value of mid, that okay, I have a true result for this particular height, but in search of the larger height, for let's suppose your mid was over here, you were standing over here, but your answer is over here, right? Because you want the greater height. So in search of better answer, just go towards the right of mid. So shift your starting index to mid plus 1. So instead of just traversing over this entire array linearly that was producing a time of big O of h, because you were traversing over all the heights, if you apply binary search, your search space gets reduced by half at every step, and hence the time required is big O of log h, because you are only traversing over maximum of big O of log h heights, because every time your search space gets reduced by half, and for every height the time required is big O of n. So the time complexity for this code will become big O of n log h. We will discuss time complexity after the code as well, but this is somehow that we are thinking of, that okay, our time complexity will become something like this and it will definitely pass the constraints. So this is how we smartly changed the linear search of height over the binary search of height by constructing a predicate function that was monotonic in nature. That is, at some points of heights it was true, and from some point till the end it was always false, and we required only the last true value, and this is something that we can do it. So let's jump onto the code and see how it actually works. So this is the code to this problem. So first of all, I took the number of test cases as input, then I took the value of n, that is the number of coders, and x, that is the maximum allowed units of water. Then I constructed this heights array and took input in that. Then I initialized my search space, the starting index with 1 and ending index to 1e12, that is some maximum value. So this tells me that my height can be as minimum as 1 and can be as maximum as 1e12. And I initialize my answer variable to some minus 1, it does not matter, we will modify this answer inside this while loop. Now inside this while loop, while starting index is lesser than equals to ending index, we are initializing our mid with the mid value of starting index and ending index. So there are two ways of writing it. You can either write it like this as well, and else you can write it like this as well. Both works. Okay, both are same, both works. So yeah. Then for this particular height, I check that whether this function is returning me true or false. So I have made a checker function. So I am seeing that whether it is returning me true or false. If it is returning me true, in that case I tell that okay, my one possible answer is this height mid, and in search of better answer I simply shift my starting index to mid plus 1. Else, if it is returning me false, this means that I have to look for a suitable height towards the left of the mid, so I shifted my ending index towards mid minus 1, and at the end I am printing the answer, which is the best possible height that I can, best possible height of the tank that I can actually build. So let's go through this checker function and see how it is returning us the desired value. So this is the check function, that is the boolean function. In this we have three parameters, that is the height, the vector heights, and the maximum units of water allowed. So I initialized my units to 0, that is if I am building a tank of height mid, then this units variable basically contains that how many units of water I actually require. I took the size of this vector heights in variable n, and I am just iterating over all the heights array value. If heights of I is lesser than mid, do you all agree? Then only I will have some water above this particular ith coral. And how much water will be there? Mid minus heights of I. If I am building a tank of height 4 and the coral is of height 2, so how much units of water is above that coral? 4 minus 2, that is 2, right? So only when heights of I is lesser than mid, my units of water will get incremented by mid minus heights of I. Once I have done this for every coral, I know I require units amount of water. If my height is mid, I am returning true. If my units is lesser than equals to x, else I am returning false. Now again, there are two ways to do so. You can even write something like this. If units of water that you require is lesser than equals to x, in that case return true, else return false. This is one way you can do. If I just simply comment it out, it is one way which you can do, or you can do it in a single line as well. That if units is lesser than equals to x, it will return true, otherwise it will return false. It's a common way of writing things like this. Okay, instead of using that if else, you can write something like this as well. So this is the entire code and logic behind this question. Let's discuss the time complexity. So for every test case, this is for loop is running for time n. This is running for log of 1e12. Log of 1e12, because initially our search space was of length 1e12, and we know that every time our search space gets reduced by 2. So this is running for log 1e12, and this checker function runs for big O of n. So in total, this while loop takes time of log of 1e12 multiplied by n. And yeah, that's all for time complexity. So you can say that, okay, the time complexity that you require is nothing but big O of n log. At max you can see 1e12, or you can take a lesser height as well, but if the height should be greater than 1e10 or something like that. Okay, so it will definitely pass the constraints, right? What's the space complexity that you require? So the space complexity is, you are building a vector height that is of size n, so it is requiring n space, and rest all other variables. Over here also in the checker function, since you are passing your height as reference, so it is not just copying, it is just pointing to the same memory location. So you don't require an extra space over here. So we can say that the space complexity is nothing but big O of n, and it will definitely pass the given constraints. So this is the entire logic to this code. I hope all of you got it. Thank you.